Yes, class. Let us start now. Mariam, please just change your name. Mariam, Khadija, Noha, Rishita, Yahya, and Zaina. All right. So, class, we have to start with electric potential. This is the last topic of the potential part. You have two portions. No, one is your capacitance, one is your potential, electric potential and capacitance. So, potential energy is the last portion. In the next class, hopefully, we'll be able to start with capacitance. Let us start with this. Now, what is potential energy? When we are talking about the potential energy or electrostatic interaction, what is meant by this? Always remember, whenever you have potential energy present, whenever you have potential energy present. So potential energy basically means the interaction. Interaction in the sense, what do you understand by this interaction? Interaction means exertion of force on each other. All right. When one particle, suppose that this is one particle which is present, fine, and this is one more particle which is existing. Now, if they are able to exert forces on each other, we will say that they are exhibiting potential energy. See, there are various causes of everything. You have the cause of kinetic energy as the change in motion. Whenever the body starts or begins its motion, we say that the body is exhibiting kinetic energy. So that is the cause. You see the motion of the body occurring, you immediately relate it with kinetic energy. Understand very well, because in the questions where multiple charges are given, you will forget how to count it. So wherever you see one charge is present, no potential energy can exist. This is not like your potential that this will be having its own potential energy. No, this is not possible for this. Yes, class, please open up your cameras, videos. Other students also. Only I have seen Yahya obeying this properly. Other students, please follow the same thing. Okay. So see, this Q1 is present. Suppose we have this Q2. One more charge, just one more charge I have brought. So whatever force of interaction is existing between these two charges, Q1 and Q2, here a force will be existing. We say that electric potential energy is existing between these two charges. Fine. So always whenever, because you have kinetic energy also in your systems, kinetic energy is very easy to identify. You get speed in your calculation. Kinetic energy has half mv square as the formula, right? That is the only formula for kinetic energy. When you are talking about potential energy, you have the concept of work done. You have the concept of forces. So what is the cause of potential energy? Interaction. And what is the meaning of this electrostatic interaction? Means basically the forces. If you see two charges are able to interact as in they are able to exert force on each other. They are able to exert attraction or repulsion forces. There would be one potential energy existing between these two. Suppose one more charge comes. Let's say this is Q2 prime. So there would be interaction between these two also. There would be interaction between these two also. So you will have three potential energies in your system. 1, 2, and 3. You should know how to count, because in your questions, you will be getting variable charges. You do not know how many charges are asked. So basically, it's the work done. This part is for your understanding. You don't have to write this in your exam, that if two charges are present or if two charges are not present, then how the charges will be interacting and how they won't be interacting. Now, when we are talking, this is just for our purpose to understand. When we are talking about the examination perspective, because electric potential energy's formula can come in the exam. Not formula, the definition. So do not write down this definition as your main answer. Potential energy is basically the work done when you are bringing a charge from infinity to a particular point. That energy, work done, gets stored in the form of energy, and that energy we call it as electric potential energy. Fine, so we'll see potential energy of system of two charges. We will start that. See, it is not possible due to a point charge, right? Because this is not a property of a single charge. So we cannot have potential energy due to a point charge, the way we were calculating for electric field or electric potential. So minimum two charges we will see. what is the generalized formula for two charges. Then we will see if n number of charges are there, how will we calculate it. So these two are the major things for today's class. Rest of the things are easy if you understand the next two portions. First, all of you write down the definition part, then I'll start with energy of a system. Class, one more thing. I was checking your homework. Only Yahya has submitted the homework of electric potential, means this chapter. He has submitted equipotential surfaces also and the assignment before that also. What about the other students? At least attempt your homework, how much you are able to attempt. I have just seen Yahya's, his papers are unchecked right now, so that's why I'm not showing his papers and discussing it. But I have only received his homework of electric potential, this second chapter. Other students also submitted by today, tomorrow at least, so that in the next class, Thursday, we can discuss it.
Done, ma'am.
All right, let us continue with this. Class, one more thing. The previous portion is not completely over. Electric potential as a gradient, electric field as a potential, gradient of potential is still there. I have told you, we'll see how to solve the partial differentiation and all. That also we will see. So let's see after this. I just wanted to start this portion first of potential energy because that is helpful for electric potential as the gradient for electric field as a gradient for electric potential. We'll try to cover that in today's class. Now see the derivation for these. Potential energy when you are discussing for the system of two charges. So we'll also have two charges only in our calculation part. Now look, suppose we have two charges which are placed in infinity. Q1 is there, Q2 is there. All right. Now there is a point A and we have brought first Q1 to this point A from infinity to A. So when Q1 was there, Q2 wasn't there. Q2 was there at infinity. We have just brought Q1 to the point A right now. No other charge is present. So if no other charge is present, will there be any potential energy existing according to all of you? Yes or no? If only a single charge is existing, that is Q1. No other charge is present. So should the potential energy exist or not? Regarding, just keep in mind the above discussion which we have discussed. if only one charge is present. Yes, class?
Yes, ma'am.
I have brought Q1 from infinity to this A point. Right now, only Q1 is present. I have not brought this Q2. Only Q1 is present. So will there be any potential energy existing? See,
Yes, ma'am.
class, one thing, please understand this very well. You have the, no, it won't exist. Now understand why it won't exist. See, potential energy only comes due to interaction. If only Q1 is there, with which charge it will be exerting any force, right? There is no interacting species present, right? So if Q1 is present, you need one more physical entity to be existing for Q1 to interact with. So when Q1 is brought from infinity to a point, our work done one means work done in carrying Q1 from infinity to A. This will be directly zero. You know potential is work done by a charge. So the potential will also be zero in this case because there is no other charge to exist. It will have its electric field, it will have its electric potential, but not force, not potential energy. These things do not exist that time. Fine. Now what I have done? Now I have brought Q2 from infinity to this P. Now at least we can say one fact that potential energy now will be existing. This is zero. Understand this part, class, very well. Initially, it was zero. Now we have brought the charge. And we know the formula of work done. Work done is charge multiplied to change in potential. Now, what we'll do, see, potential at infinity will be zero. Definitely. Potential at a point at infinity, this is zero. But potential at P point is not zero. Why? Because we have already studied it's the potential due to a single charge Q2. So what will be the potential? K, but not Q2. Why, class? See, when we are talking about the potential getting existed on Q2, this is due to which charge? This is due to Q1, right? We are talking about Q2, so our charge would be Q2. This charge, this is Q2. But what about the potential? Potential is because of the Q1. This potential is existing. This sphere of potential is existing around Q1. That is exerting forces on Q2, right? That's why we won't consider K Q2 by R1. We'll consider K Q1 by R1. R12 means the separation between Q1 and Q2 that we take. So see, very easy. This part is very easy. This would be K Q2 divided by R1. Now what would be the complete work done from infinity to this point B? Q2 getting multiplied to K Q2 by R1. So basically you have the work done which is present. This is K Q1 Q2 divided by R1. Now this is just from infinity to B. Work done 1 was already 0. Work done 2 is KQ1, Q2 by R12. So total work done will also be this. This is the work done. So this work done gets stored in the form of potential energy. So if it's stored in the form of potential energy, now pay attention, class. This is your actual formula which you will be using. K Q1 Q2 divided by R12. R12 I'm just writing for here. K Q1 Q2 by R. For two charges, whenever two charges are existing, K Q1 into Q2 divided by R. K, you know, 9 into 10 to the power 9. Q1 is first charge, Q2 is second charge, divided by the separation between them. That's it. Similar to your other forces formula also, there we had R square. Here we are just having R, not R square. Fine. This formula is important for your entire concept of potential energy. Now we will see for n number of charges, but first write it down, class. So if a derivation comes, this you will show the entire, make this figure also. This is a figure from your textbook only, because this is drawn in vector form. That's why we have this R1, R2 written. and the separation between them is taken as R. Write it, then we'll see for n number of charges. Done, class?
Yes, ma'am.
Okay. Let us start with the n number of charges which are existing. See, now if n number of charges are existing, we'll again have the same. We have Q1, Q2, Q3, Q4 up till Qnth we have. So when we'll bring Q1, same thing. For Q1, the work done would be 0, right? For the first charge. And when Q2 is brought, Q1 and Q2 are existing. That also we have studied. If Q1 and Q2 both are existing, that will be K Q1, Q2 divided by R1, 2. This much we have already studied. So I'm not going into the details of this. Now, if Q3 is brought, we'll see up to 3 charges. Then fourth one, fifth one, you can automatically conclude by yourself. Yeah. See, now I have brought a third charge from infinity to this particular point C. Now what we have? See, V infinity is 0. ये तो पक्का clear है? V infinity will be 0. We are talking about Q3, but what is VC when we are talking about VC? Because VC is not just due to Q1 this time. Earlier for Q2, we just had one charge, so we could get it. Now VC, what is VC actually equal to? VC, when we are writing work done, this is Q3 multiplied to. What exactly is VC equal to? Look in the figure. Q3 is existing over here. Now have a look over here. If Q3 is existing over here, for the potential due to Q1 and Q2 this time, this would be the difference. Earlier, when we had 2 charges, we used to put one potential due to Q1. Now, this potential will also be existing. This potential will also be existing. Total potential would be exerted on Q3. So, here we'll have K. Now, Q1 into Q3, right? No, this is just KQ1 divided by R13, right? By R13, because we are talking about the potential of Q2.3, that is C point. This is C point to this C. So this is R13. This is R23. This is R13. This is R12. Just so that you remember what is the separation and which charges are we talking about. So this is KQ1 by R13. Now what about the potential due to Q2? This is plus KQ2 divided by R. This is 2, 3, right? Between 2 and 3. This is the total potential that we have right now. Now let us multiply Q3. Let us open up the bracket. Let us just multiply this. So the work done 3 this time is K Q1 Q3 divided by R13 plus K Q2 Q3 divided by R23. Now look class. Suppose we have brought fourth charge. This series will go on. It will continue how you would write it. Because every time you cannot, if you have 11 charges in your exam paper, you cannot start with this. That 1 charge is coming, 0, 2 charges coming, 3 charges coming, 4 charges are coming. Even if it is 11 charges, you can write. What about 50 charges, 100 charges? You should have a proper formula. But before the formula also, you should know if you have less amount of charges, let's say Q1 was there, work done was 0. Q2 came, so we had 1 potential. Why? Because of this. 2 charges are giving you 1 potential. K, Q1, Q2 by R1. Now we have Q3 as well. So 1 potential between them, second potential between them. Okay. Now we are talking about Q3 due to Q1 and Q2. So what will be the potential due to this? K, Q1, Q3 by R13. What will be the potential due to these two? K, Q2, Q3 by R23. See, Are we getting the same answer from this? The same calculation, we were getting the same answer. I'm repeating. This part I'm repeating so that you can predict for Q4 also. We are just saying Q1 is present, Q2 is present. Now we are calculating due to Q3. What is the force or energy between these two and between these two? So K, Q1 into Q3, these two first we are talking. Q1 into Q3, and what is the separation between them? R1. Come to these two. K, Q2 into Q3 divided by R. If these two charges were existing, we have done this. Suppose let's talk about a fourth charge. So if a fourth charge is existing, before going by the actual formula, see, now Q1 is existing, Q2 is existing, Q3 is existing, and we have Q. So one energy due to this, K, Q1, Q4 by R14. Second energy due to this, K, Q2, Q4 by R24. Third energy due to this, K, Q3, Q4 divided by R3. If you have 5 charges, so K, Q1, Q5, K, Q2, Q5, K3, Q3, Q5, K, Q4, Q5, like this. Now let's come to the formula part. So again, the same thing. When we have the work done for, so what all formula do we have? K, this is Q1, Q4 by R14 plus. You have then K, Q2, Q4 by R2, R24. Then you have plus K, Q3, Q4 by R34, like this. So these were also fixed, so we could calculate. If we have the nth number of charges, so what is the general formula? So can you see when 4 charges were existing, we had 3 energies. 1 charge existed, we had 0. 2 charges existed, we had 1. Then 3 charges existed, we have 2. 4 charges existed, we have 3 potential energy. So how can you write the general formula if suppose n number of charges are present? K Q1 Qn by R1n, K Q2 Qn by R2n, K Q3 Qn by R3n, like this till n minus 1. Means just one less than that. See here also when it was 4, 1 less than it. Because equal to would be Q4 again. So you cannot have 2 Q4s. That's why n minus 1 n. So these are all the energies we have accumulated. We have work done 1, we have calculated work done 2, we have calculated work done 3, work done 4, and everything. Let us add all of these because we still do not have the general formula. This is still that manual calculation, no? Still we have not calculated the general formula. So let's do one thing. Let's add all of them. So the work done would be, first would be 0, second would be K, Q1, Q2 by R1, 2. Third would be K, Q1, Q3 by R13 plus K, Q2, Q3 by R23. Okay, 4 also we have calculated like this. This is 1, 2, 3. I'm not writing everything because those are 3 numbers. Till what we have, this one. K, Q, n minus 1 into Q, n by R, n minus 1. N minus 1 comma n means R12, R23, R34, like this. Find us. Again, I'm repeating this part. What is this? This is your work done 1. What is this part? When you have, this is work done 2. What is this? This is work done 3. Like this. What is this? This is work done nth. Like this you have. This is the total work done. This total work done gets stored in the form of potential energy. So potential energy will be exact this. I'm not writing it again. This is exact this. It gets stored in the form of potential energy, right? So if n number of charges are present, what would you do? For individually, you will be calculating these charges individually. one charge is present with that charge, like this. So how can you still write the general formula that we have? If you want, you can write this as K. I'm writing it as 1 over 4 pi epsilon naught. See, summation of I is equal to 1, then J is equal to 1. This is a method to write in, I think you must have Ij means any term starting from 1 to nth, summation till Rij. This is difficult. You can remember. Easy way to remember is K, Q1, Q2 divided by R. But the method you have understood, if you have n number of charges, if you have so many charges, if 4 charges are present in a square form, in a triangle form, so all of these will be interacting among themselves. Wherever you see that 2 charges can exert force, directly say there would be a potential energy between. Write it down. Now we'll see questions practicing, but write down this part. Let us discuss this class. 2 charges are only given. I have not increased the number of charges. Potential energy we have to calculate. See, what all things we have. We have charge as 2 millicoulomb. 2 millicoulomb means 2 into 10 to the power minus 3 coulomb. What is the second charge? Minus 3 microcoulomb. Potential energies, all these are scalars. So we'll take it as minus 3 into 10 to the power minus 6. This is micro, so minus 6 coulombs. Separation radius, what is this? 3 millimeters. It is 3 into 10 to the power minus 3 meters. So first part says potential energy. Easy. We have to calculate K, Q1 into Q2 divided by R12. That is R.
Ma'am, I have a
So
doubt.
yes, say.
Does magnitude matter in this type of question?
No. Here in potential, it does not matter. That's why we are taking minus 3 into 10 to the power minus 6. Because these are scalar quantities, no? That's why. In vectors, we calculate the direction separately. That's why we keep in mind to take the magnitude. Right now, you can always take the as it is value. Okay.
Okay.
So K is 9 into 10 to the power 9. Charge is 2 millicoulomb, 10 to the power minus 3. Then Q2 minus 3 into 10 to the power minus 6. This is R. 3 into 10 to the power minus 3. 1 minus 3, this 3 would be cancelled. So this is minus 18 into 10 to the power 9 minus 6, 3 joules. So what is our potential energy? It is minus 18. Negative sign is showing something. I'll tell you. Yeah, the question you were asking. Let me clear it more for you. See, why are we not considering the magnitude part, which he was asking also? Class, there is a significance about it. Potential energy can be either positive or it can be negative, right? These are the two only possibilities. In between, there's nothing can happen. When the potential energy comes positive, this shows that system is unbounded. System is unbounded means the charges are not bounded to each other. Negative system shows that system is bounded. This is bounded. So if system is bounded, this shows that this is a stable system, right? Charges are bound. That's why we take the signs also. Now this is a stable system. But one more thing. This is the work done. This is the potential energy. Second part says the work done. So work done to make the system is the entire potential energy. So answer for the second part is same, 10 to the power 3 minus 18, 10 to the power 3. Now, third part is saying decide the system is bounded or unbounded. So by looking at this, what have we seen? Right now, potential energy, this is coming negative. So
It's
system
bounded, ma'am.
bounded, yes. System is bounded. Last part is if bounded, then calculate work done to break the system. Whatever is the work done to make the system is the negative C of work done to break. So we have to calculate work done to break the system. It would be negative of work done to make. Make means this. See, we had made it. Remember, Q1 was coming Q2. So break would be plus 18 into 10 to the power 3. Write down the solution, class. Yes, class. So how many potential energies are existing according to you in this figure? Just tell me the number of potential energies which are existing according to you. I have shown you the figure. I have told
4,
you how
ma'am.
to calculate the potential energies. I'm not asking the final answer, just number.
4, ma'am.
Any other answer by name.
3.
Yes, correct. See, 6. Why have you forgotten these diagonals? They also will be interacting, no? These you have calculated well. 1. See, this is the first. This is the second. Here you will have the third. Here you will have the fourth. What about this? These two will also be having fifth, right? These two will also be having energies because they can interact, they can exert forces on each other. That's why you will have 6 potential energies in this particular figure. All right, you will see the arrangement also. This is a geometrical figure. Now, one thing. These 4 separations and charges are very clear. But these two do not have the separations. But you know, this is A, this is A. And we have calculated these kinds of figures, especially the square one, a lot of times. So this side should be clear to all of you. This is the perpendicular, this is the base, this is the hypotenuse. So AC, which is equal to BD, both the diagonals, they are equal to under root A square plus A square. That's it. So this becomes A root 2. Remember, we have done this so many times when we have also calculated the half of these. A by root 2 we were getting. So this would be A root 2 only, right? Now let us start with the potential energies. Yes, Khadija. Khadija, tell me the first energy. This is first charge. This is second charge. This is the separation between them. Yes, Khadija.
Yes, ma'am.
How much, Khadija? How should we start?
Um,
K.
K. Wait.
Q. What is the second charge?
Q and positive
Q.
2Q.
Divided by what is the separation between Q and 2Q?
A.
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 Only A, not square. K,
Oh, yeah.
Q1, Q2 divided by R. You have written this formula, so
Yeah.
that's okay. Good, Khadija. Amina, this one, BC.
Ma'am, can we write this as 2k q square by a?
2K, 2K Q
Q,
square by A.
yes.
That you have to write. That you have to write.
Ah,
Here in this part, I am only discussing how to write it. Without that, how will we solve the question? Because that is the simplification, calculation part that you will do. See, when you will solve the question on your own, when you will write the questions on your own, you won't be taking so much time. No, this is because we are discussing in the class. That's why a lot of time is being taken. Yes, Amna, can you tell me between BC,
K. 2Q.
K, 2Q
2Q minus Q
minus Q divided by
by A.
A. Very good. Divided by A. Okay. Mariam Batul. This one between D and C. These two charges.
And minus 2Q into
K
K.
come first.
Yeah, K
K
minus 2Q
minus 2Q
minus Q
into minus Q
by A.
by A. Very good. K into 2Q minus 2Q into minus Q by A. Who is next? Nuha, can you tell for this fourth one? These two? Nuha, Sheen? Yes, Nuha. These two charges, see, other students have also answered in this manner. Answer quickly, Nuha. You're present in the class, Nuha. Are you attending? Are you listening? Nuha? Nuha, answer, otherwise I'll remove you from the meeting. Yes, Nuha? Okay, you're present. Yes. So you're not able to unmute yourself, Nuha. What is happening? Mic is not working. Write in the chat column. Okay, it's okay. Write in the chat column. I hope you are understanding, Nuha. I just wanted to know your presence. Can you just try? These two charges are present. Can you try how to write it? See, we'll start with K. Then what should we multiply quickly? Just use the chat column quickly, Nuha. Everybody is waiting. Yes, Nuha. Quickly. Microphone is not working. You can use the chat column, na? यहाँ पे बता दो. K has been written. You have these two charges. Which 2 points? Are you not listening in the class, Nuha? Which 2 points are we discussing now? We have discussed these 2 points. We have already calculated these two. We have already calculated these two. Now we are discussing between A and D. A point and D point, between these two. A point and D point. Just tell me what should I multiply next? How much time will it take you? K into Q into minus 2Q. Very good. Divided by? This is correct. A. Very good. So this is K multiplied to Q multiplied to 2Q divided by A. Perfect. So these four are clear. Now we have the diagonals. Rishita, can you tell for AC? Yes, Rishita.
Yes, ma'am.
AC. The diagonals. Fifth one.
K, Q,
K into Q.
minus Q by A
Q
into
will
minus
be
Q by A.
multiplied divided by
2A,
divided by
2A,
2A.
no, oh, sorry, A root 2.
A root. Yes, very good. This separation is A root 2, no? So yes, good. This is A root. Correct. Siddhika, can you answer this last part? BD? Just this is left. Yes, try Siddhika. These two charges, BD. Yes, this is B point. This is the D point. Siddhika, what we'll write? K into Q into minus Q. Why Q into minus Q? This we have already solved. Rishita has already answered. You're telling now between AC. No, this Rishita has answered. BD. This charge and this charge. Sixth one, last one I'm asking. These two charges. So why Q and minus Q? This Rishita has already answered. These two. K into, instead of Q, it will be 2Q. Instead of minus Q, it will be, yes, minus 2Q. Now it's correct. Very good, Siddhika. Correct. Divided by A root 2. So this is how we have calculated all the interactions, and this is how you have to calculate all the interactions which are exist. Okay. Now for the solving part, one thing which Yaya was already saying, that Q square by A, we can write it. But one thing I'll tell all of you, one thing is common in all of these. K q square by a. So instead of first writing this separately, then taking out the common, let us take the common directly here. So we are left with 2 kq square minus 2 kq square by a is taken common plus 2. From here minus 2 kq square by a. So minus 1 by root 2. And from here, how much? Minus 4 by root. 2 minus 2, 2 minus 2 would be cancelled. We have our answer. This is minus 5 by root 2. So minus 5 kq square by root 2. This is the final answer. See, so even 4 charges were present. This is the answer we were getting. Write down this class now. Any doubts if you have, please let me know. Class, one more thing. Now to pay more attention on all of you, we have decided that we'll split the batch into 2 groups. Okay, one batch will come at 9 p.m. the way you all are coming, and one batch will come before this, that is 6:30. So that less students are there in one batch and each of you can get attention. So just confirm with me, Rishita, Zaina,
Yes, ma'am.
is Zaina Rishita is present. Zaina is not there. Okay. Mariam Muhammad is not there. Mariam Batul is there. Mariam Muhammad is not there. Amina. Amina is present. And Yahya. You all are available for this timing, 9 p.m.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
And the second batch is Nuha. She's present. Yes, she's present. Sidra is also present.
Yes, ma'am.
Next we have Khadija. She's present. Siddiqa. She's present. And Mariam Batul. That was Mariam Muhammad. She's absent today. Mariam Batul. Are you all available for the 6:30 timing?
Yes.
Ma'am, I'll be there for 9.
Mariam
Ma'am,
for
same.
9. And Sidra, what about you?
Yes, ma'am. You also for 9.
For 9. And Khadija?
6:30 is fine.
6:30 is fine for you. Khadija.
Yeah.
Okay. So Mariam and one more student. Who said? Sidra.
Yes, ma'am.
Sidra and Mariam. Okay. And what about you, Siddiqa? Okay, Siddiqa is answering. Ma'am, I'm comfortable. This current timing, that is 9 p.m. Okay, then I'll inform the team about this. I think all of you are comfortable with this timing only. Most of you are comfortable with this. Only Khadija is convenient with both the timings. Fine. I'll just inform the team. Yes, Mariam, I've noted. I've noted. Done, class?
Yes, ma'am.
Okay. See, since I wanted to discuss that electric field part, but since we are now in the flow of potential energy, let us complete this. After completing this, I'll come to that partial derivation of electric field as a gradient of potential. So let us complete this. Let us introduce torque in our questions. See, these everything that we have discussed, these were due to individual charges that we had seen. Now we have the concept of dipole. If a dipole is existing, so what all things will come in our calculation. Now, class 1 formula you all must remember, torques. What was the torques formula? Can anyone tell? Torques formula we have done. Yes, Khadija, can you try?
PE sin theta.
Very good. PE sin theta. That is P cross E, which is equal to P E sin theta. Why are we using torque here? Because see, if a dipole is existing, we have discussed it can move, it can create one angle theta 1, it can move like this, it can move here also, it can create theta 2 also. So torque is responsible for all these rotational forces, right? That's why we have torque present. Now, when we are talking about the rotational motion, see, when we were talking about the linear straight line motion, we have work done is equal to force into displacement. Now we have the rotational motion. So force is analog. You must have studied in your class 11th. Rotational motion. Force becomes torque. Linear displacement becomes angular displacement. All these are rotational analogs. Fine, class. So here also we'll have work done is torque dot theta. This is force dot displacement. Instead of force dot displacement, we have torque dot d theta from theta 1 to theta 2. This is what we have. Now, let us put the values. Khadija has already told us the value of torque. So this will be PE sin theta d theta. We have just put in the value from theta 1 to theta 2. Now, when we integrate sin theta, we get minus cos theta. So PE, these are constants. When you integrate, you get minus cos theta from theta 1 to theta 2. What is work done? Work done is minus PE now. We put the upper limit first. Integration you all now know. Upper limit first instead of theta. So this becomes minus sign I've already taken out. Fine. So I'm just writing cos theta 2 minus cos theta 1. Fine. Entire work done gets stored in the form of change in potential energy. What is the change in potential energy? U2 minus U1. If you're getting confused with the change is the simply difference between these. Anyways, what is our final answer for potential energy now? If we are talking about the potential energy, what is the answer for this? So we have change in potential energy or potential energy as minus PE cos theta 2 minus cos theta 1. Class, one thing, sometimes you will not see this minus sign in some formula in other books. That means they have just taken cos theta 1 minus cos theta 2. This basic mathematics, all of you know. If you reverse them, sign will change. So minus PE cos theta 2 minus cos theta 1, if you can use this, or use PE cos theta 1 minus cos theta 2. Similar thing. I follow this. If you want, you can remember this or the other one positive also. Answer will be the same in both the cases. For example, let's say our theta 1 is suppose 90 degree and theta 2 is some random theta. Because this is a very common case that we have where perpendicular dipole is mentioned. So in that case, our potential, this will become minus PE cos theta. This is also used a lot for the purpose whenever the dipole is perpendicular. Anyways, I'll discuss this with you. What about the individual dipoles which are present, individual movements? This I'll discuss in detail. Do not worry about this. First, right now, this is a very, very small derivation, very small derivation. This can come as your 2-marker question or a 3-marker question. very small derivation distance, but this can come. This is not very important. This derivation part is not very important. I would say that more than this, the derivation of this formula, PE sine theta, this is more important. But anyways, anything can come in your exam. But whenever you are revising, pay more attention to this derivation which we have done. Write it. Class, we have already discussed this. Work done by electric field is negative of work done by external force. This is the same thing. It's just that in questions we'll be using. Now look, if dipole is parallel to electric field, theta will be 0. So this becomes minus PE cos 0. This is minus P, the potential energy. So negative means minimum potential energy. That is very stable. I have told you, no, bounded. This is very stable. If it is 180 degree, that is anti-parallel, then cos 180 degree will become minus 1. So this becomes plus P. So this is the maximum potential energy that is possible because this is the maximum angle, this is the maximum value plus PE. But since this is positive, we have our system unstable. So negative potential energy is good for us. And if you have it perpendicular directly, potential energy will be 0. Make this stable, class. And first write down this line just once again. See class, this question says that an electric dipole of 2 coulomb meter is placed in an electric field of 10 Newton per coulomb. So what is the data that we have? We have electric field as 10 Newton per coulomb. And what is the dipole moment that we have? 2 coulomb meter. Okay? These are the two data that we have. So we have to calculate work done by external torque in rotating dipole from parallel to anti-parallel. Parallel means 0 degree. So theta 1 is 0 degree. To what? To anti-parallel. Theta 2 is 180 degree. See, this is the parallel. This is the anti-parallel. Now for the first part, we'll put the value for work done. This will be minus PE cos theta 2 minus cos theta 1. Fine, cos theta 2 minus cos theta 1. So, what will this be? Minus 2 into 10. Why 2? Dipole is 2. Electric field 10. Cos theta 2 means cos 180 degree minus cos theta 1, 0 degree. This is minus 20. 180 cos 180 degree is minus 1 minus cos 0 degree is 1. So this is actually minus 20 multiplied to minus 2, which is equal to 40 joules. Second part is work done by electric field in the part 1. Easy, just minus 40. Both are negative. So work done by the electric field. This will be plus, no, this will be minus. Minus 40 joules. Third part is saying potential energy difference. So these were the work done. Potential energy difference would be what? Potential energy difference is the same thing. Whatever work done has in part 1. Do you need to calculate it separately? All of this work done only gets stored in the form of potential energy because it is specifically mentioned part 1. So 3, this is directly potential energy. This is 40 joules. Last part, fourth is left. What is the fourth part saying? Calculate potential energy if dipole is placed at 60 degree with respect to the field. See, here the other angle is not mentioned. So in such cases, you will use just this formula, minus PE cos theta. Do not use that elongated one. When one angle is given, no, that means other angle is automatically 90 degree. Be careful with this. Directly use this formula. So minus 2 into 10, 60 degree. So half. So this becomes minus 10 joules. Fine. Why? Because theta is 60 degree. That completes the potential energy, entire concept of potential energy. Just a small part of 15 to 20 minutes is left from your potential. In the next class only, I'll be starting with capacitance. So I'm not shifting any timings because most of you are convenient for this class only. If there is any change, I'll ask you first. Write this down, class. I hope
Ma'am,
this entire topic of potential energy is clear to all of you.
yes, ma'am.
Others, clear or not?
Yes,
ma'am.
ma'am.
Ma'am, can you show the question again? Thank you. Done, ma'am.